Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to calculate the pH of different solutions. One is a strong acid solution. One is where you dilute that solution a certain amount, and I'll show you how to do that. And we're going to need to watch out for the auto-ionization of water. So let's get into this. Okay, so in this problem, we're asked to calculate the pH of the following aqueous solutions. So, excuse the voice. So the first solution is 1.5 times 10 to the negative 5 molar HCl. Now, HCl is a strong acid, so since it's a strong acid, we know that the HCl is going to completely ionize in water. That's what it means to be a strong acid. You're going to be like pretty much 100% completely ionized in water, which means that for every mole of the HCl molecule you have, you're going to get that many moles of the H plus ion. Since it's a 1-to-1 ratio here, that means that whatever the molarity of the HCl is, that means that's also going to be the molarity of the H plus ion. So in this case, so for A, because it is a strong acid, the HCl concentration is going to be equal to the H plus concentration, which is going to be equal to 1.5 times 10 to the negative 5 molar. Okay, so since we got that, finding pH is just finding the negative log of the H plus concentration, because that's what pH means, right? So pH is equal to the negative log of the H plus concentration. Since we know the H plus concentration is 1.5 times 10 to the negative 5, we can then plug that in, and that's going to be negative log times 1.5 times 10 to the negative 5 molar. And when we take that calculation, we get 4.82 for the pH. So the pH is 4.82. Okay, so that's part A. Now, what about part B? So part B says we're going to take 1.0 milliliters of sample A. So here's sample A with its concentration. We're going to take a milliliter of that, and we're going to put it into 0.50 liters. We're going to dilute it to 0.50 liters. And so let's go ahead and do that. So whenever you're diluting something, we're going to have to figure out what the new concentration is. So the first thing we're going to need to do is we're going to have to figure out how many moles of the HCl or H plus is in 1 milliliter of this solution. So let's go ahead and do that. So we have the molarity, right? And we're going to take 1 milliliter of that. And so we know the volume times the molarity is going to give us the number of moles, right? So, and the reason for that is if we take 1.1 milliliter, right? And we're going to put that over 1 milliliter of the H plus, or HCl, let's just call it HCl. It's, even though it's just H plus, 1 molar of the HCl of the HCl solution. So HCl solution. In order to use molarity, would you have to convert this to liters? So we know that there are 1,000 milliliters of HCl solution is equal to 1 liter of the HCl solution. So milliliters cancels out. And then we have liters. And now we can use the molarity, which is going to be 1.5 times 10 to the negative 5 moles per liter, because that's what molarity means. So we're going to have 1 liter of the HCl solution on the bottom, and we're going to have 1.5 times 10 to the negative 5 moles of HCl on top. So that's going to cancel out. Liters of HCl solution is going to cancel out. Now we have moles. So all we have to do is do the calculation, multiply by everything on the top, divide by everything on the bottom, and we get, what do we get? 1.5 times 10 to the negative 8. So we get 1.5 times 10 to the negative 8 moles of HCl. And as we said, this is going to be the same as the number of moles of H plus, because remember, in water, it's going to be fully ionized. And so this many moles of HCl is going to be the same as that moles of H plus ions in the water. So now all we need to do is divide this by the new volume. Well, what's the new volume? We got to be careful here. We're taking 1 milliliter of the original solution in A, and we're going to add that to 0.50 liters, right? So we said here, if we divide by 1,000, we get liters. So that's going to be equal to 0.001 liters, right? So we're adding this to 0.50 liters. So we add that to 0.50 liters. And so that's going to be equal to 0.501 liters. Now, for the rule of adding and subtracting with regard to sig figs, since we're adding 0.001 here to 0.50 here, the least number of sig figs would be, or at least number of decimal places is what we're looking at. So this has 2 decimal places, this has 3, so we would have to limit this to 2 decimal places, but we'll keep an extra one for rounding errors. So this, we need the complete, the total volume. So we have the total volume, so we take the moles and we divide it by the total volume. So here we got 1.5 times 10 to the negative 8, and I'm going to put H plus ions because that's the same as HCl, because that's a strong acid. I'm going to divide it by 0.501 liters, and we should get a concentration of H plus, and that's going to be 2.994 times 10 to the negative 8, and that's equal to the H plus concentration. Okay, now before you start calculating pH, we ought to notice something here. Notice that this negative 8, the concentration of H plus, is very close to that that's in water already. Remember, neutral water or pure water has a pH of 7, which means that for neutral water, let me put it down here, for pure water, I should say, for pure water, we have a neutral pH of 7, so pH equals 7, which means that the H plus concentration is equal to 1.0 times 10 to the negative 7 molar. So That is the H plus concentration from pure water. This is the H plus concentration from the 1 milliliter of acid that we took here from part A. These are not very different from each other. So this differs by, about a factor of 10, which means that the H plus concentration of water is not going to be negligible. We can't ignore it. So we're going to have to do an ice table with the auto ionization of water to see what the shift is going to be in adding this concentration of acid to the 0.5 liters of water. So we got to go ahead and do an ice table. So let's go ahead and do that. So I'm going to erase this, and we'll set up our auto ionization of water. So we have 2 H2O, right? Let me write that out so it's clear. So the auto ionization of water is where you have one water molecule acting as the acid, and you have another water molecule acting as the base, and you get a transfer of a hydrogen from one water molecule to the other. Right, so this water molecule will donate a hydrogen to this water molecule, and so you get the hydronium ion, because this one's going to add a hydrogen, this one's lose a hydrogen, and we're going to get the hydroxide ion, right? And this is our H plus ion. And so if we do an ice table, right, remember, for water, that's liquids. So liquids don't participate in the ice table. We ignore that. So we're not going to do anything with these. So we'll go ahead and just ignore those. And we're going to look at this just here, right here. So here, what we have here is, again, our concentration of H plus is 2.94 times 10 to the negative 8. We're going to put that for our initial concentration. So we're going to put 2.994 times 10 to the negative 8. And then for the hydroxide ion, we're going to start with a concentration of 0 for the hydroxide ion. So before any of the auto ionization occurs in the water, we'll assume we'll start with that amount, since that's what we added to the acid. That's what we added to the water. And we're going to start with 0 for the hydroxide. And then we're going to see the change. And since this is 0, we're expected to shift in this direction to fill in the hydroxide ion. And so that means that we're going to gain an X amount here, and then we're going to gain an X amount here. And so if you add those together, you're going to get 2.994 times 10 to the negative 8 plus X. And then you've got X here. And so now we can put it into our excuse me. Pardon me. Sorry about that. So the equilibrium expression for the auto ionization of water, again, it's not going to include any liquids. So it's going to simply be Kw, which is for the auto ionization of water, is equal to the concentration of H plus, or the hydronium ion, H3O plus, times the concentration of the OH minus. Since liquid water is the reactants, we don't put that on the bottom. So this is your equilibrium expression for the auto ionization of water. And so all we have to do is put these into here. So then Kw, which is equal to 1.0 times 10 to the negative 14. That's going to be equal to the H3O plus concentration, which is this right there. So we have 2.994 499, or 2.994 times 10 to the negative 8. 2.994 times 10 to the negative 8. And then we're going to, oh, sorry, I forgot the plus x. Then we're going to multiply that by x, which is the OH minus concentration. And so now we have everything in terms of x. So now all I have to do is solve this equation. It's going to end up being a quadratic equation. So then we'll have to use the quadratic formula. So let's go ahead and work this out a little bit. So if we multiply x through, we'll get 1.0 times 10 to the negative 14 is equal to 2.994 times 10 to the negative 8 times x plus x squared. If we bring this over, we subtract 1.0 times 10 to the negative 14. On this side, we'll subtract 1.0 times 10 to the negative 14 on that side, and then we'll have our quadratic equation in the proper form. Let me erase this to give myself some more room. So then what we're going to have is 0 is equal to negative 1.0 times 10 to the negative 14 plus 2.994 times 10 to the negative 8 times x plus x squared. And so now we can use our quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so this is going to be c, this is b, and then we have a 1 there. The 1 is a. So then we plug in our a, b, and c here. So then x is going to be equal to negative, and we can round this to 3 to make it simpler. So negative 3.0 times 10 to the negative 8 plus or minus the square root of negative 3.0, oops, not negative, sorry, that's going to be just positive, 3.0 times 10 to the negative 8, and that's going to be squared, minus 4 times a, which is 1, times c again, which is negative 1.0 times 10 to the negative 14, so negative 1.0 times 10 to the negative 14, and then all of this divided by 2 times a, which is, a again is 1, and so now we do our math. So you do the math and you end up with, let's see, x is equal to, so x is going to be equal to, this is going to be a negative 1.5 times 10 to the negative 8 plus or minus 1.01 times 10 to the negative 7. Okay, so if you subtract, we can see right away that we have a negative here. If we subtract this from this, then it's adding a negative to a negative, and we end up getting a negative value for x, and obviously we can't have a negative value for x, so that can't be right. So what we're going to have to do is we're going to have to subtract this from this. We're going to have to add this amount to this amount. Since this is larger, we're going to end up with a positive value. And so when we take this number and we add this number to it, we get x is equal to, let's see, 8.6 times 10 to the negative 8. So now that we found x from the autoionization of water, remember our H plus concentration, or our hydronium ion concentration, was in terms of x, right? So if you remember before I erased it, the H plus concentration, or the hydronium ion concentration in our ice table, that was equal to 2.994 times 10 to the negative 8 plus x. Well, we just found x, so that's going to be equal to, if we round this to 3, right, 3.0 times 10 to the negative 8 plus 8.6 times 10 to the negative 8. And we should get a total of let's calculate that. And that's going to give us 1.16 times 10 to the negative 7. And then to find the pH, all we have to do is take the negative log of that number. So pH is equal to the negative log of 1.16 times 10 to the negative 7. And we get a pH of 6.94. 6.94 is the new pH. So that was the new pH after we took 1 milliliter of solution A and diluted it in 0.5 liters of water. So I hope this is helpful. I hope you enjoyed the video. If this helped you in any way understand how to do these sorts of problems, then please, by all means, like the video, share the video, hit that like button down there. Also, subscribe to my channel, help me out here. Also, hit that notification bell. When you do, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.